to be switched? It has to be switched. You're right, Drew. So we said it's a trinomial. Everyone pretty much agreed on that in class. Online, do we agree with that? Is this a trinomial?
Yep.
Yes. If we wanted to rewrite this into standard form, because Drew said it's not correct as it is, what would we have to put first?
17x to the second.
Yes, Drew. 17x to the second power. 17x squared would come first. Then what?
5x.
5x. Good, Lily. Good, Sarah. And last, we would do the
-1.
the -1. Good, Sarah. So our final answer in standard form would be 17x squared plus 5x minus 1. Okay? That is what we did yesterday. We talked about polynomials. We identified them by their number of terms, and we talked about how to put them in standard form. Today, for the third time, okay, everyone listening? Today, we are going to be adding and subtracting polynomials, which pretty much is combining like terms. Okay? So another pretty easy day. Go to lesson 2. It's the next page. Online, if you're typing them in, make sure you're going to your copy in your drive. If you have them printed out, so Jack K, Aiden, you guys were here yesterday, so you should have the hard copy at home. You can just write them by hand. Okay? I'm going to present the notes for you guys so you can see them as I fill them in. And we'll do some examples together. Everyone has something to write with? Yes?
Yeah, I do.
Kane, you got something to write with?
Yes.
Maddie, you're good. Dalton, you got something to write with? Okay. All right. So let me lift this up a tiny little bit because we were way too zoomed in. Alrighty. Does someone want to hit the lights? Because you guys can't see it in class clearly. Let me turn this on. Whoa, I'm losing my chair. Remember, if we can stay somewhat quiet in class so people online can hear, that would be wonderful. You will have plenty of time. Not right now when we're starting the notes. When we're adding polynomials, we need to make sure that the exponents and the variables are the same on the terms that we're combining. So you can basically, if you have an x squared, you can only combine it with an x squared. You can't combine it with an x to the third or a y squared. They have to be exactly the same. So it's like playing a matching game, right? If you have matching cards and you match them up, they have to be exactly the same. You can add them horizontally. I'm not going to tell you which way to do, okay? That's up to you. I'm going to show you both ways, and you pick which one you like to do better, okay? When you add them vertically, you're going to write the like term exponents in columns under each other. Add each column separately. Fill in the blank spots with zeros if it helps you. When adding horizontally, you can just identify your like terms and combine them. And that's how we've done it in the past. I'm going to show you both ways, okay? So in example 1, I'm going to slide this up a little bit. It says add 3x squared plus 14 and 5x squared plus 2. So they want you to add these two expressions together. They're two binomials that you're adding. So where it says and, that's like your big plus sign. You want to add those two together. Okay? Now, the first way I have it set up is vertically, up and down. Notice I have my 3x squared and my 5x squared above each other, right? One on top of the other. These two don't match up. So what the directions up here, what the instructions were saying to you, is if it helps you, you can write it this way. 3x squared plus 0x plus 14. And then 5x squared plus 2x plus 0. Do you have to do that? No. If it helps you, that's fine. I filled in a 0x there as a placeholder because I don't have any just regular x terms in my first binomial. I put a 0 down here because I don't have any just numbers without a variable in my second one. Again, do you have to do this? No. If it works for you, then go ahead, okay? When you add these, you're just going to combine them up and down like you would normally with addition. So if I have 3x squared plus 5x squared, how many x squareds do I have? Anyone can call it out.
7x.
What's 3 plus 5?
8.
8. Good, Sarah. 8x squared. If I have 2x's plus 0x's, how many do I have? 2. Good. And 14 plus 0?
14.
14. That would be my final answer. I just combined my like terms. Okay? You guys at this point in the school year haven't seen it set up that way, but it is an option. So far, so good? Yes? Example 2, I'm going to show you horizontally. And then you guys can pick which way you like better. If I'm adding this horizontally, I'm going to pick out my like terms. So which two pieces can I combine together? My 4x to the third power and my 1x to the third power can be combined. So when I add 4x to the third plus 1x to the third, what do I get? 5x to the third. Good. Do I have anything to combine with my minus 2x? No. Good, Sarah and Lily. So I'm just going to bring it down. So minus 2x. Do I have anything to combine with my minus 4? No, Lily, you're right. So I just bring it down. Okay. So horizontally is when you can use those underlines. You can circle the common ones. You can put squares around them. You can highlight them. Whatever works for you. You're just combining your like terms. Does everyone understand what we're doing when we're adding polynomials? Yeah? So I'm going to do one more example with you, and then you're going to do the other 5. And then we'll review them. So the directions say add the following polynomials. I'll do this first one with you. Y squared plus 3y plus 2 and 2y squared plus 4. If I want to add these all together, do most of us, let me take like a poll quick, horizontal or vertical? Do you like just combining your like terms horizontally and picking them out? Or do you like to set them up vertically up and down? Which way would you choose out of the 2 examples?
Horizontally.
Horizontally? What about you guys in class? You don't care, Lily? Drew, what works for you? Whatever. Maddie, what works for you? Dalton? Horizontally or vertically? I'm just going to go horizontally then because most of you are used to that. Okay? So I'm not going to take the time to set them up on top of each other. So I'm going to try to pick out my like terms. I'm going to start by looking for my highest exponent. My highest exponent is a 2. So is there anything I can combine with this 1y squared?
Yeah, the 2y.
Yeah, you're right. The 2y squared. So what's 1 plus 2?
3.
3. Good. 3y squared. Another trick you can do when you're doing this is cross them out once you use them. So I use that y squared and I use this y squared. Again, you don't have to do that. It's just another trick I'm showing you. Is there anything I can combine with my 3y?
No.
No. So I'm going to add 3y. I used it so I can cross it out. I have a 2 left and a 4 left. Can I combine those?
Yep.
Yeah, what's 2 plus 4?
6.
6. That's my final answer, and it's in standard form. I want you guys to do the other 5 right now. Okay? So take some time and get those 5 done.
Can I turn on the lights for a second?
Yes. You may turn on the lights for a second.
fine. Thank you.
You're welcome. Hi, Dan. I just saw your chat. I see that you are logged in now. So we're just going over lesson 2, which is adding and subtracting polynomials. Okay. We've done this in the past. We're pretty much just combining like terms. All right. So I went through 2 examples and then I just did a 3rd practice problem. You guys right now are working on the other 5. And then we're going to go over them because these are going to be like your formative assessment questions, just so I can see that you guys understand before we move on. Online, how are we doing? Do we need another minute or are we ready to go over these?
1 more minute.
Okay. So while I'm giving you another minute or 2 to finish these up, I'll just briefly state that I did look at the do now responses from yesterday where I asked for your feedback. And many of you said that you prefer teacher examples and slow down pace, which is kind of what we've been doing, right? I've been going through a lot of examples. I'm breaking down the lessons into smaller topics, right? So I'm glad that this model is kind of working for us better. And I think there was 2 or 3 students that also wrote that they don't like Pear Deck and Jamboard, that it doesn't work for them. I think I had 1 student write that Jamboard does work for them. So I'm going to kind of try to steer clear from using that if we don't have to. Okay. Does that sound cool with everyone?
Yeah.
Yes. Obviously, some lessons we need to use technology like that. But I will try to be more straightforward with just teacher examples, practice, and a slow pace and let you guys have time for your own work. Okay? So I'm trying to take your feedback into consideration when we're moving forward this marking period. All right? Okay, are we ready to go through these? Now, these are your, I'm seeing that you guys are ready to move on from addition and move into subtraction. So I'm going to be calling on you guys and relying on you guys to help me fill these in. Okay? So let's look over here to the right problem. We have 6m squared minus 2m plus 10 and m squared minus m minus 8. So we want to add those 2 polynomials together. What kind of polynomials are we adding if there's 3 terms? What are they? If there's 3? A trinomial. Good, Lily. Good, Drew. So we're adding trinomials. Okay? If I have a 6m squared, is there anything I can combine that with? M squared. Good, Lily. So 6m squared plus 1m squared is how many? Good job, Lily. 7m squared. What do I combine next? Negative 2m and negative m. Maddie and Lily, good job. When I do negative 2m minus 1m, what do I get? Negative 3m. Good, Maddie. And lastly, what 2 pieces do I combine?
Negative 8 and 10.
Negative 8 and 10. Good, Sarah. Negative 8 and 10, when you combine them, you're left with how much? 2. Good, Lily. Plus 2. The girls are holding on the fort today. 7m squared minus 3m plus 2 is the correct answer. Okay? Moving on. I'm going to slide those up so we can see all four of these. Negative p plus 4 and 5p squared minus 2p plus 2. Notice this time we have a binomial and a trinomial. That's okay. You can still add them together. Okay, they don't have to be the same number of terms. This time I'm going to call on, let's see. Oh, I see Lena, you just logged in too. Hi, Lena. We're going through lesson 2 of the notes. Okay. Let's see. Rosie, I'm going to go from the bottom up on my list. So Sarah just answered. So Rosie, what's something that I can combine with these two polynomials? P. You're right. I can combine the p term. Is there anything I can combine with the 5p squared? Anyone can answer this. Can 5p squared get combined with anything? No, you're right, Lily. So I'm just going to bring that down. And then like Rosie said, I can combine my p terms. Rosie, when I combine negative 2p and negative 1p, how many am I left with? Let's see if Rosie gets it. Yep. Rosie put 3. Lily's answer is just a little bit better because she said negative 3p. But Rosie, you're right. You get 3. So minus 3p. And then what are the last two pieces I have to combine here?
Oh, yeah. 2 and 4.
Yes, Sarah. 2 and 4. So 2 plus 4 is 6. All right, Kane, you're up. Yes. Let's look at this bottom left one. What's the first term? Yes. 4t squared.
Yeah.
There's nothing to combine with that, right? What would I write next? What would I combine?
Oh, 5.
Yes. 5t and?
Negative 7.
Can I combine 5t and 7?
No, and 14.
Can I combine 5t and the 4t?
Yeah.
I can? What does the 4t have with it that the 5t doesn't? The squared. So can I put them together? No. So we just 4t squared is the first thing I write. You're correct. But then you told me I can't combine it with anything. And you were correct again. So I used that guy. Okay? He's gone. So then you said I can combine something with the 5t. I have a negative 7, an 8t, and a 2. Which one's going to go with the 5t? The 8t. So 8 minus 5 is how much? 3. Good. So plus 3t. I use them now, Kane. So what's the last thing that I have to do?
Combine the 7 and the 2.
Combine the 7 and the 2. You're right. So negative 7 plus 2 is going to give me how much?
5.
Negative 5. Good job. Okay. Dan, do you agree with Sarah?
Yeah.
Yeah, I'm going to take my minus 4d to the third and my minus 2d to the third and combine them. So I'm going to get minus 6d to the third. Thanks for helping, Sarah. And then Dan, last question for you. I used those. So what's my last step? What do I have to do?
Combine the 7 and the negative 2.
You're right. 7 minus 2 is plus 5. Good job. Before we move into subtraction, which is the same thing, okay, there's just one extra step that you have to be careful of with subtraction. I'm going to go through an example with you, and then there's 6 problems. So same thing we just did with addition. Do you want to push through and get this done, or do you want to take a break quick and then do subtraction? Break? Okay. So I will give you in a 7-minute break. So you have till 10:50. Okay? 10:50, we're going to start subtraction. So moving into subtraction. Okay? Same thing. We're still combining terms. There's just one extra little step that you have to be careful with subtraction. When you subtract polynomials, it's important to remember to change all of the signs in the subtracted polynomial and then combine like terms. So here I want you guys thinking about the distributive property. Okay, so let's look at this first example. It says 4y squared plus 8y plus 9 minus this whole entire polynomial, not just minus 2y squared, right? Does that make sense? Does everyone notice that? So since it wants you to subtract this whole entire polynomial, that minus sign actually is like being distributed in here like a -1. So it's going to change all of your signs. Okay? That's the only tricky part about subtraction. So step 1, write the subtraction problem in vertical form if you want to. You don't have to. You could still do this horizontally. Okay? Make sure you line up the terms with the exponents under each other that are like. Okay? So in this step, all I did was I rewrote it in up and down form, in vertical form, so that you can see it a little bit better. And I put here, think of the distributive property. In step 2, change the subtraction sign to addition and all the signs of the subtracted polynomial to the opposite sign. So basically what this step did is it took that minus sign and distributed it to all 3 pieces. So now I have a -2y squared. Notice this plus 6y changed to a minus 6y. And then we had a -4 that's now a +4. Does everyone see the differences there? Okay. And then they're going to combine this up and down. So when I combine this, I have 4y squared minus 2y squared. It's going to leave me with 2y squared. I have a positive 8y minus 6y is a plus 2y. And a plus 9 and a plus 4 is a plus 13. And that's my final answer. Okay. Can you do it up and down vertically like this? Yes, 100%. Do you have to? No. Okay. I only wrote out one example like that because I know I'm going to do another one with you right now. Okay. So let's look down at the practice problems that you're going to be doing in a second. It says, directions. Subtract the following polynomial expressions. Based off of what I just instructed you to do, what am I going to have to do with this minus sign? Someone tell me.
It becomes a -1.
It's like a -1, Sarah. Right. Maddie, what were you saying? Yeah, you can. Maddie said turn it into an addition sign. That's going to be my next step. After I take this and change all of these signs, like Sarah said, turn that into a -1. And you can put the 1 there if you need to. Okay? Then Maddie said I'm just going to put a big plus sign between both of these because I'm going to combine them. So did anything change in this first polynomial, in this first trinomial?
No.
No, you're right, Sarah. I leave it. So 2x squared plus 5x plus 2. I know I'm lefty and I'm sorry my hand and shadow covers it until I move it away. Now I'm going to do what Sarah told me, and I'm going to change all of those signs in my second polynomial because I'm multiplying by -1. I put my plus sign like Maddie said because I'm going to start combining my like terms. So -1 times x squared is a minus x squared. Now, this is where some people might get confused. All right. So Maddie, if you don't write this, you're just going to write minus x squared, which is fine. Okay. Can you write that plus sign? Yes. All right. Just don't get confused here. -1 times 3x is a minus 3x. And then a -1 times a +1 is -1. Now we're ready to combine. So let's pick out my like terms. Is there anything to combine with 2x squared? Yeah, what? The x squared, the minus x squared. So I have 2x squared and a -1x squared leaves me with 1x squared. Does it help you when I cross them out, the ones that we used? Doesn't matter? It does? So we used 2x squared and we used -1x squared. Now we have 5x. Is there anything I can combine with that?
Negative 3x.
Good. Sarah and Maddie got that. We have the 5x minus 3x is plus 2x. I'm going to cross those out because Lily and I like crossing them out once we use them. And then we have a plus 2 and a minus 1. What do I get when I combine those? 1. Good, Maddie. I know I'm moving super slow. For some of you, this is probably painful. But is this making sense? Can we do the next 5 problems on our own? Yes? Okay, go ahead. Take a few minutes and get these last 5 problems done. So let's just move down this time underneath. I have 8y minus 4 minus 4y plus 3. So what am I going to do first? Dalton, you help me out with this one. What am I going to do first? Rewrite it. So do I have to do anything with this first part, the 8y minus 4? No. So I write 8y minus 4. Then what? What would I write next? Okay. Plus negative 4y minus 3. Again, if you guys like writing the plus minus, that's fine. Okay, just don't get confused by that. All right, so Dalton, help me rewrite it. Like, what am I going to combine? 8y, negative 4y, you're right. So 8 minus 4 is 4. And then, let's see. AJ, you want to help me with this last part? Since you just got in? What else is there left to combine in this piece? If I combine my 8y and my minus 4y. Yeah, you're right. Negative 4, negative 3. AJ just got that and she wasn't even here for the whole lesson. So I'm going to combine my negative 4 and my negative 3, and I'm going to get negative 7, and I'm done. Yep. Yeah. Negative 2m minus 8. What do I have to do with this minus sign again?
Make it a plus sign.
Make it a plus sign, and then what? What does it do to the other 2 pieces?
Make a positive.
It makes them what?
Negative.
It makes them negative. Thank you, Sarah. So I take this negative sign, Cain, and I bring it into those parentheses. So what am I going to write here?
Add the negatives.
Cain. What am I going to write? I have negative 2m minus 8, and then what?
Negative 2 minus 8 would be negative 10.
No, this 8 doesn't have an m with it. I didn't even write the problem yet. Come on, pay attention.
You said negative 2 minus 8.
Yes, I have that so far, but I didn't finish writing this down yet. I'm asking you, what do I have to write here?
6m plus 2.
That minus sign doesn't matter?
Oh, yeah, it does.
So what?
Minus
6m
minus 2?
minus 2. Good. That's all I was asking. All right. Drew, finish this up for me. What is my final answer? Yep.
Negative 8m minus 10.
Minus 10. Sarah, do you agree?
Yep.
Okay. So those are the 6 problems. Do we have any questions on those? Dalton, please turn the lights on for me. Where are they? Here's a green one. That works. All right, Dalton and Drew, come on. You guys should be working too.
We're doing this. Okay. Where's my? I'll come. Alright, you okay? Yeah, Drew. Yeah.
Okay, solve that problem.
Done? No.
You did it?
Know if I did it correctly. Hold on.
Well,
No.
ask your partner to check.
I'm so good.
You guys are done?
I'm the accurate checker.
Yeah, I know.
That is not a 6.
All right, let me check.
I break my P with the frick.
7 to the third
No, she cheated. Didn't she?
plus 2z squared. Good. You got minus 3z and a plus z. The minus 2z,
You did
good.
it wrong, right?
And plus 2, good. Dalton and Drew, let's say
Uh-oh, I'm scared. I did too quick.
That's a 6, by the way, not like a.
5p to the third plus 3p to the third. Where's my 5p to the third plus 3p to the third? Why do we have,
Wait, it's already 2 pieces.
what's 5 plus 3? Fix it.
Come on, bro. Come
Fix
on. You know what 5 plus 3 is?
No.
Oh my god. Dalton.
No, I did it wrong on purpose, I swear.
Oh, no, I just messed up my braces. Can you write it for me?
Good, looking good so far. Keep going. Yes, those are your 3 pieces. Now, what's the correct order to write it in? Which one has to come first?
How do you do 5 plus 3? 5 plus 3.
That one's hard.
Good, now you can help them out. 2n squared, then what?
Whoa, you look at me like that. Nah.
Okay,
You can calm down.
and then?
Is this right?
No.
Where'd you get the minus from? Is the 10 bigger or is the minus 6 bigger?
Jeff, go ahead.
Boys, did you finish yours?
12 less.
5p to
It's
the
a
third
game.
plus 3p to the third is 8p to the third. Minus 4p
You
squared
forget your phone.
minus
I
3p
got
to
taken
the
away.
Oh my god.
Good. Better.